Welcome to the case study series in Information Technology by Skilled MBA. Intel faces mounting strategic challenges in an increasingly competitive semiconductor landscape. Key among these are manufacturing delays, notably in transitioning to 7 nanometer and 5 nanometer nodes, which have placed the company at a technological disadvantage. As rivals advanced, Intel saw market share erosion, particularly in the mobile and AI chip segments, where major customers turned to alternative suppliers. Compounding these issues is Intel's growing reliance on foreign manufacturing, raising national security concerns within the U.S. technology ecosystem. This case explores the implications of these shifts and the urgent need for strategic reinvention. Intel faces strategic challenges, including manufacturing delays with 7 nanometer and 5 nanometer nodes, leading to technological setbacks. The company has seen market share erosion in mobile and AI chip segments, losing key customers. Additionally, there's a growing dependency on foreign manufacturing, raising security concerns within the United States technology ecosystem. Intel faces fierce competition from Taiwan Semiconductor Manufacturing Company and Samsung in manufacturing, and Advanced Micro Devices and NVIDIA in central processing units and graphics processing units. Technological lags and a declining mobile chipset presence have led to losing key customers like Apple. Additionally, Intel is falling behind in artificial intelligence-optimized chip architecture, impacting its competitive edge. Pat Gelsinger's return as CEO in February 2021 marked a pivotal shift for Intel. By March, he introduced the Integrated Device Manufacturing 2.0 strategy, aiming to rejuvenate Intel's manufacturing model. In the second quarter, Intel Foundry Services launched, signaling a major business model evolution. By the third quarter, the Smart Capital strategy was unveiled, committing $100 billion to manufacturing. The Smart Capital strategy involves a $100 billion investment, marking Intel's largest capital allocation. This funds new manufacturing facilities in Arizona, Ohio, and Europe, aiming to advance next-generation process nodes. The focus is on regaining manufacturing leadership through unprecedented infrastructure development. Intel's transformation involves shifting from solely producing its own designs to offering contract manufacturing services. This strategic pivot demands a cultural shift from an integrated device manufacturer to a service provider mindset. The new model includes core Intel products, foundry services, government contracts, and other services, broadening Intel's market reach and operational flexibility. Semiconductors are vital for United States national security, especially in defense applications requiring a trusted supply. Taiwan's TSMC concentration poses geopolitical risks, with China tensions heightening supply chain concerns. Nations are forming strategic alliances to secure semiconductor supply chains and pursuing domestic manufacturing to reduce dependency on limited suppliers. The CHIPS Act allocates $52 billion to bolster domestic semiconductor manufacturing and research. With $39 billion in manufacturing incentives, it supports building advanced fabrication facilities in the United States. An additional $13 billion is dedicated to research and development for next-generation technologies. Intel emerges as a key beneficiary, with government backing mitigating investment risks. Balancing R&D investments with manufacturing expansion demands significant resources. Rebuilding engineering excellence is crucial to counteract brain drain. Regaining trust from key customers like Apple and Microsoft is essential for proving reliability. Transitioning from an integrated device model to a hybrid approach requires overcoming organizational resistance. Investments in research and development and manufacturing's expansion will initially strain finances, with revenue growth lagging behind. Capital expenditures are projected to rise significantly, impacting short-term profitability. Shareholders should anticipate reduced dividends as resources are allocated to strategic initiatives, setting the stage for long-term gains. The automotive computing market is expanding, driven by advanced driver assistance and autonomous systems, necessitating specialized chips. Artificial intelligence acceleration presents a strategic opportunity with rising demand for training and inference chips. Edge computing, an emerging segment, requires low-power, high-performance chips for processing at network edges, highlighting significant market potential. Intel's technological innovation focuses on the Intel 4 process, utilizing extreme ultraviolet lithography to compete with rivals. The Intel 3 process enhances transistor performance and power efficiency, set for 2023. Intel 20A introduces the groundbreaking ribbon-FET architecture, while Intel 18A aims for manufacturing leadership by early 2025. Legacy technology giants face the challenge of reinvention in fast-evolving industries. Optimal resource allocation requires balancing innovation investments, capital expenditures, and shareholder returns. Companies must strategically navigate the intersection of technological advancement and national security interests to maintain competitive advantage and align with geopolitical priorities. Bold leadership with industry insight is crucial for transformation. Strategic capital allocation involves significant investments to reclaim technological leadership. Innovating business models by expanding from products to services opens new revenue streams. Aligning with national security priorities and securing government support is essential for success. For further insights into technology strategy, Skilled MBA offers a wealth of resources. Access case studies and learning materials tailored for Master of Business Administration, students and professionals. Connect with us via mobile at +1 87553 00795, email at support@skilledmba.com, or visit our website at https://skilledmba.com.